Okay, today we're going to start section 2. In section 2, we're talking specifically about rate of change. I think you guys probably were introduced to this some in pre-algebra. Yes? Does anyone remember talking about rate of change?
Yeah, but it was confusing.
Sometimes instead of calling it rate of change, we used another word. Does anyone remember what it would be? Slope. Did you guys talk about slope last year? Yeah? Okay, so we're splitting this into 2 days. Today we're going to talk specifically about rate of change, which rate of change and slope are the same thing, okay? A lot of times, well, it just depends. Sometimes they'll use rate of change, other times they'll call it slope, okay? But what rate of change is, it's just, it's a change of how quantity changes with respect to another quantity, okay? So we're going to write a few things down of what rate of change is. So rate of change, same thing as saying slope, okay? Now, how we're going to look at this specifically today is the change in y over the change in x. The other way we'll look at is when we have a graph and we use rise over run. So if we have a table of values, we'll use change in y over change in x. If we have a graph, that's when we're going to use rise over run, okay? Now, there are actually, well, really one other main way we'll talk about slope, which we'll talk about tomorrow, but that's when we're given two ordered pairs. So today, we're just looking at these two ways first, change in y over change in x, and then rise over run, okay? Now, before we start looking at it, I'm just going to remind us of the 4 different types of slope. So if you want to write these graphs down, you don't have to make your graph take up your whole paper. I'm just going to make mine a little bigger so that you can see them. It's okay, Eric. I think they're just clowning around, yeah. So these graphs are going to show the 4 different types of slope, okay? Now, is there anyone that can identify any of these 4 types of slope? So let me give you the 4 types of slope. There's slope of 0, there's undefined slope, there's negative slope, and there's positive slope, okay? Does anyone think they can tell me any of those 4 just from looking at the graph, JC?
Positive, negative.
Okay, tell me like top right, top left, where you're at.
Top left, positive.
Top left is positive. How would you know that?
It's going up.
Good, because it's going up. Because we read left to right, so as I go from left to right, my graph's going up. What about the one on the top right?
Negative.
I know it's negative because it's going down. Okay, and then I have to decide, I have undefined slope and I have a slope of 0.
Slope of 0 is bottom right.
Very good. Now, the reason that is because when we talk about slope, slope is the change in y over the change in x. Well, is this y value ever change? Yes or no? No, right? This y value stays the same every time, so that change would be 0 divided by anything. Well, what's 0 divided by anything? 0, okay? The last one, bottom left, would be undefined slope. Okay, same idea here. This x value never changed, so it doesn't matter how the y values change. There could be a change in 4, but if the x values never change, can you divide something by 0? No, right? I can't take you guys and put you into zero groups. It's not possible. When you try to divide by zero in your calculator, it tells you what? Error, because it's not possible to divide by zero. So that's why a vertical line is undefined slope. A horizontal line is a slope of zero, okay? Which we've seen this type of graph before, yes? Didn't we just see this on our worksheet that we did last week? Yeah, this was like x is equal to -2. This one, y is equal to +3, something like that, okay? So that's just a reminder of what slope looks like, positive, negative, undefined, or slope of zero. Now we're going to go talk through the two different ways that we will find slope or rate of change, okay? Now, I'm not going to make my table of values very fancy. I'm just going to draw a line between them and list them, okay, just for time's sake. Okay, so when you're given a table of values, right, what way did I tell you at the very beginning to use to find my rate of change? Look at the very first things we wrote down. Which one do we use for table of values? Rise over run or change in y over change in x? Change in y over change in x. So all you have to do is look at how do my y values change each time. So how do I get from 15 to 9? By doing what? -6. How do I get from 9 to 3? -6. What about 3 to -3? -6. So it works. You have to check all the way down. Okay, I'll tell you why in just a second. How do I get from 1 to 2? +1, 2 to 3, +1, and 3 to 4. Also +1. Okay, so as long as those numbers stay the same every time, now I can write a fraction for my rate of change. All I do is take the change in y, which was what number? -6, and I put it over the change in x, which was +1, and then I just simplify. How would I simplify -6 over 1? Do what? Oh, yes, we do. Do I ever leave a fraction over 1, you guys? No. So it'd just be what? Yeah, just -6. Okay? Yeah. All right, we just don't ever leave a fraction over 1, so that's all you have to look at when we're doing that. Okay? All right, we're going to look at a couple more of those. Okay, so on the x values, we have 2, 4, 6, and 8. Y values 12, 24, 36, and 48. Okay, all right, so Jesus, can you tell me how my y values are changing every time? How do I get from 12 to 24? +12. What about 24 to 36? And 36 to 48? Also +12. Okay. All right, Eric, what about my x values? How are my x values changing every time? Adding 2. What about 4 to 6? And 6 to 8. Also 2. Okay, so who can tell me how I would set up my rate of change then, using those two numbers? Which one goes on top, the y or the x? Change in y, which was 12, over the change in x, 2. And then I just simplify. Can you divide 12 by 2? Yes. What's 12 divided by 2? 6. So the rate of change here is 6. Okay? Now, sometimes, let me just give you, sometimes instead of x and y, they're going to give you, let me look at this. So, this is the amount of gas in gallons. and then the cost in dollars. So 4.75 gallons cost $15.77. 6 gallons costs $19.92. 7.25 gallons costs $24.07. And 8.5 gallons costs $28.22. Okay. All right. Now, is this one going to be a little bit trickier than the last ones? Yes, because we have decimals. Do you guys have your calculators? Okay, take your calculator out because you're going to want that. Bless you. Okay, how could I find out how I get from 1577 to 1992?
Divide 19.92 or subtract.
Yeah. We could just subtract them, right? Okay. Somebody subtract that for me and tell me what you get. $4.15. Now, is this going to be the same number every time on these? Maybe not, right? Because they might be going in different increments, but let's just try it and see. Okay. What about 2407 minus 1992? It might be. Is it 415? Okay. 415. Let's check the last one also. 2407 and 2822. Well, and that just depends on which way you subtract them, but it's still, we're going up, right? So it'd still be positive 415. Yes. Okay. All right. Now, let's do the same thing on the bottom. Subtract 4.75 from 6. Should give you 1.25. Yeah. Okay. 6 to 7.25, also going to be 1.25. Same thing on my last one. So, now, does that mean that the cost is 4.15 cents per gallon? Yes or no? Why, Sebastian? You're correct. It's not $4.15 per gallon. How do we know it's not? Anybody? Yeah, because right now we have 415 over what number? 1.25. Now, if it was over just 1, sure, that would mean it's per gallon. But we need to divide this. So somebody divide 415 by 1.25. $3.32. Okay, so that just tells us that the amount is $3.32 per gallon. Okay. All right. Questions on this? Not too bad. Feel okay with it? We can all do this, yes. Okay. All right, let's look at a couple graphs. I'm gonna... Okay. Now, here's the deal. When they give us a graph, I wrote next to it what we're going to use to find our slope. What do we use? Rise over run. Now, you might put out to the side. Rise is either up or down. Run is left and right. So here's why I think this is the easiest. All you have to do is locate two ordered pairs on your graph, okay? I'm going to locate one right here, and then we're going to say, I drew my graph a little poorly, but we're going to say it goes through the origin right here. You'll be able to tell because your graphs will be perfect. All right? Every time you're going to start at the left point and go to the point on the right, okay? So if I'm at this left point, would I count up or down to get even with the point that's on the right? Up, how many? How far is that? From this point, 1, 2, 3, 4. Okay? So that means I went up 4. And then how far to the right would I have to count? Over 2. Right? Because I would be sitting here, and then I would count 1, 2. So what would my fraction be for slope here? If I went up 4 and right 2.
4/2.
4 over 2. And then I would just simplify that to what number? What's 4 divided by 2, you guys? 2. Okay. All right, same idea here. Now, I'm going to give you a point. Looks like there's one here and here. Now, same idea. I want to start with the point on the left, so that would be this point. What direction would I count to get even with my other point?
Down.
Down how many?
3.
So I would go down 3. So now, what type of number, if I'm moving down 3, would I use?
Negative.
-3. And then left or right? Right. 1, 2, 3. Okay. So then, Aiden, if I'm writing this as a fraction, what would my fraction be? -3 over 3. Okay. Can I divide 3 by 3? Yes. What's 3 divided by 3? 1. And I have that negative, so my slope is going to be -1. Okay. Make sense? All right. Do we feel like we're okay with this today? Do I need to do another example on the graph, or we can handle it? Okay. Today, we're just practicing these two things on Delta Math. Okay. Truthfully, I'm not even going to make you get out a white. Well, you can get out the whiteboards if you need to. You probably won't because you're just essentially counting and then writing a fraction in simplest form. Okay. So we're practicing those on Delta Math today.